times greater. Well, times greater is not subtraction. It is going to be sorry about that. Times greater is going to be division. So I'm going to divide 8.3 times 10 to the 7th by 1.892 times 10 to the 6th. You can do this division in your calculator. I suggest you do it so you don't have to do long division there. That would take a long time. And I get 4.38689217. Always just round to the hundredths place. That's a good rule. So it's 4.39 times, and then here I just subtract my exponents. 7 minus 6, which is equal to 10 to the first power. So it's about 4.39 times 10 to the first power times greater. All right? Or, if you wanted to, you could multiply by 10 and it would be 43.9 times greater. Okay? So hopefully that helps with the front of that. You guys, most of you did that in class. But now we're going to continue with the back side. And let's see what we have for the back. Planets. We got a lot of planet stuff because it's scientific notation. I'm going to zoom in a little bit. All planets revolve around the sun in an elliptical orbit. I don't know if you know what elliptical is, but it's kind of like a squish circle. That's elliptical. Uranus's farthest distance from the sun is approximately 3.004 times 10 to the 9th kilometers, and its closest distance, so that's farthest, this might be closest if this is the sun here, who knows, is this number. Using the information, what is the average distance? To find average, I'm going to add up the two distances. And then I'll divide it by 2. Luckily, it's the same power of 10. I don't have to do any converting. And now it's just straight up addition. 5.783 times 10 to the 9th. And then I'm going to divide by 2 because I have 2 data points. That's the average. And I can actually do 10 to the 0 power, which is 1. So that's going to leave me with 10 to the 9th power. And then 5.783 divided by 2 is 2.89, about 2.89 kilometers average distance from the sun. There you go for that one. And we continue. This is the problem set. I don't know how many of you are going to get to this, but if you do, here are the answers. This, simply we're converting this to scientific notation. Lead factor has to be between 1 and 10, so it's going to be 6.8127. Then I take this and I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 places. And that becomes my exponent. And I prefer scientific notation, of course, because I don't like all those zeros. It's hard for me to write. Less zeros, yay. Masses of the inner planets. We got some heavy planets here. Order these planets from least to greatest. I'm going to first start with my exponent. 23 and 23 are the same. Then I look at my lead factor, 6 and 3. So Mercury is the lightest. Then Mars, or the least massive, I should say, not lightest. Then we have 24, 24, 4, and 5. Then it goes Venus, and then Earth. Least to greatest. The difference between the mass of Venus and Mars, Venus, 4.8685 times 10 to the 24th. Mercury is 3.3022 times 10 to the 23rd. Unfortunately, we got to change this because they have different exponents. So it gives me 48.685 times 10 to the 23rd. I notice I made this one less, because this increases. I moved the decimal one place that way. And then I have 3.302. Did I do something wrong? 3.3022, 4.86. Oh, that's right. Times 10 to the 23rd. And I need a little bit more space. 10 to the 23rd stays. 5 minus 0 is 5. 8 minus 2 is 6. Uh-oh, what'd I do? 48,685, 3.302. Oh, that's supposed to be a 2. Sorry. Let me back up. I made a mistake. First time ever. 3.3022. Right? I think that's what we're supposed to get here. All right. Now I got to borrow a little bit. I was just trying to avoid borrowing. Who likes to do that? I just like to steal. And here we have 45.3828 times 10 to the 23rd kilograms. Now I have to change this to scientific notation. I make that between 1 and 10. 4.53828 times 10 to the 24th kgs. Okay? And the average mass, I'm not going to do that one. I'm getting a little tired. I better do it. I'd be setting a bad example. I'm going to add these together. 3.3022. I'm going to make this 48.685. I'm going to make Earth 59.722. And I'm going to keep Mars at 6.4185. And all of these are 10 to the 23rd. I just converted those in my head. Maybe you can at this point. That's a 7. 7 and 2. I have 10 and 7 is 17. 10, 11, 12. 9, 10, 17, 21. Carry my 2. 5, 13, 22. And 6 is 28. 28. And 6 and 5 is 11 times 10 to the 23rd. Here, I need to move my decimal back 2 places. So it becomes 1.181277 times 10 to the 25th power kilograms. But we want the average, so I'm going to divide it by 4 times 10 to the 0. And let's see what I get. I'm going to use a calculator for this one. 1.181277 divided by 4. And I get 0.295 about times 10 to the 25th. I change it to scientific notation. I get 2.95 times 10 to the 24th kilograms is the average.